All right, so let's jump right in. If you're a systems designer, you've probably faced this problem. You need to send a perfect high bandwidth video signal. I'm talking 4K, 60 frames a second over a long distance.
Mhm.
And your traditional copper cables, they hit a wall, the signal starts to degrade, and you get failures. It's a huge headache.
It is. And that physical limit is precisely the problem the DVIGear DVI-7318 was engineered to solve. It's for those situations where you absolutely cannot compromise on resolution over, really long runs.
So our mission today is to get past the marketing specs.
Right. We want to unpack how this little box actually achieves what some might call future-proof performance.
Okay, let's start with that performance ceiling then. What are we actually carrying here? We're talking HDMI 2.0, HDCP 2.0.
And that means we're pushing the absolute limit of what consumer video can do today. So 3840 by 2160 resolution, it's 60p.
Which requires just a massive amount of bandwidth. I think it's, what, 18 gigabits per second?
Exactly. That 18 Gbps number is everything. It's the throughput you need for totally uncompressed 4K video, even with 12-bit color depth.
So not just the video?
Not at all. You've got your professional-grade multi-channel audio, too, up to 8 channels of LPCM. I mean, it's a huge digital load to manage.
And the question is, how do you keep that signal perfect when you're running it the length of, what, 3 football fields?
And that brings us to the distance, right?
Yeah.
This is where things get really interesting for installers.
Yeah, the DVI-7318 can extend that full 18 Gbp signal up to 1,000 feet. That's about 300 meters.
Mm-hmm.
And here's the kicker. It does it with just a single strand of fiber optic cable.
The single strand.
Yeah.
And that's where fiber just blows copper out of the water.
Why is that?
Because you're sending light, not an electrical signal. It means you're completely immune to environmental noise.
You mean like if you're running cable near heavy machinery or something?
Exactly. High power equipment, radio antennas,
Yeah.
all that stuff creates RFI and EMI that can corrupt a copper signal. With fiber, that problem just disappears.
So for sensitive applications like, I don't know, medical imaging or a broadcast studio?
It's mandatory. You just can't risk any data loss or interference in those settings.
Okay, so that makes sense. But how? How do you get 18 gigabits of data down one single thin piece of fiber? It sounds, well, kind of impossible.
You hit on the real secret sauce here. It's a technology called SWDM, or short wavelength division multiplexing.
Okay, break that down for us.
Instead of needing, say, 6 separate fiber strands to carry all that data, they figured out how to pack 6 discrete optical channels onto that one multimode strand.
So they're sending different colors of light down the same cable?
In essence, yes. They're using different wavelengths of light from 780 up to 1,000 nanometers to carry everything in parallel. It's incredibly sophisticated engineering.
That's amazing. So the physical challenge is solved, but what about the intelligence? The source and the display have to be able to talk to each other, right?
Of course, you need that digital handshake. The unit supports bidirectional DDC signals without any extra cables.
And DDC is what enables the ED and HDCP communication.
Exactly. ED is basically the display telling the source, hey, I can handle a 4K 60 signal. Without that handshake, you just get a black screen. It's that simple.
And I imagine for installers, having flexibility there is key.
It's everything. So this unit lets you either pass through the EDI directly from the display, or you can flick a micro switch and use a cache EDI that's stored right in the transmitter. It gives you control.
That's very clever. And what about powering these things?
Also very convenient. The units themselves are surprisingly light, but they're housed in these rugged metal cases, and you can power both the transmitter and receiver from a simple USB port with an optional cable. It just, it makes those tricky installs behind a monitor so much easier.
So if we boil this all down for you, the designer listening, what's the big takeaway? You've got this device that handles extreme performance, that 18 Gbps data load, and it solves the distance problem with incredible elegance.
It really is elegant.
One single noise-immune cable running 1,000 feet.
Right. And I think the key insight isn't just the distance. It's the sheer level of sophistication that's hidden inside that simple metal box.
The SWDM technology.
The SWDM. The fact that a systems designer can plug in one tiny cable and trust it to carry 6 simultaneous optical data streams. I mean, it's a testament to where high bandwidth connectivity is headed. It's a system built for absolute, unwavering data integrity.
And that's the shortcut to being well-informed. We cut through the noise to bring you the core insights on why this kind of technology is the necessary solution for modern 4K video. That's all for this deep dive.